Alright, next. You have a drawer with 5 pairs of white socks, 3 pairs of black socks, and 1 pair of red socks. 1, 5, 3. Find the probability that you choose white socks on Monday and red socks on Tuesday. White socks on Monday and red socks on Tuesday. So that's going to be the probability of selecting white socks on Monday times the probability of selecting red socks on Tuesday. What is the probability of selecting white socks on Monday? Let me hear from Damien. 5 over a total of how many pairs? 9 pairs of socks. We're going to multiply that times probability of selecting a red sock on Tuesday. Let me hear from Josh Wallace. Sorry, Josh. Yeah, the probability of selecting a red sock on Tuesday. There's 1 red sock, and you said over 9? Let me ask you this, Josh. When you wear your socks on Monday, when you get home, what do you do with them? You put them in the laundry. Okay. I think most people will do that. So how many, if you put those socks in the laundry, how many total pair are in your drawer now on Tuesday? What did you say? 8, right? 8. And we're assuming that laundry day is like over the weekend. So it's all fresh and ready to go on Monday. Okay, 5 over 9 times 1 over 8 is 5 over 72. Yes? What's that decimal come out to be? 0.069 becomes what? Yep, 0.07. And 5 over 72 is the reduced fraction. Now, freeze for a second. I just want to ask you this question. Oh, go ahead, Sedona. Right, okay, so this one was 5 white socks out of 9 total on Monday. So it's pairs of socks. Talking about pairs. Good question. So there's 5 pairs out of the 9 pairs. We'll multiply that by 1 pair of red socks out of 8. Now I know what everybody does nowadays. You don't even care. You don't even try to match. Who actually matches their socks anymore? I know, I do too. I do too. But the rest of you cool cats, if you have 2 socks, that's gold, right? I mean, one could be pink and one could be blue, and that's fine. Right?
One can't be long and one can't be short.
Yeah, that would be a little awkward to have one long and one short. I'm with you on that.
Oh, yeah.
We're calling each other out now. Okay, does anybody have questions over this any longer? All right, now let's go down here to find the probability that you choose white socks. Oh, by the way, I just wanted to ask you, this situation, is it an independent or a dependent situation? I can't hear you. Is it independent or dependent situation? What does the second day do? Does it depend on the first day?
Yes.
Yes. So it is dependent. Okay, find the probability that you choose white socks on Monday and Tuesday. White Sox on Monday and Tuesday. So the probability that you select White Sox on Monday and White Sox on what? White Sox on Tuesday. What is that? That's going to be the probability. Selecting White Sox on Monday. Plus the probability of selecting White Sox on Tuesday. Is that right? Plus? Plus?
No.
No. What is it? Times. Probability of multiplying the probability of White Sox on Tuesday. Now, what is the probability of selecting White Sox on Monday? And I'm going to call on Skylar. What'd you say? How many total Sox do you have on Monday? 9. And how many Sox were white? What'd you say? 5. Good. So we're going to multiply that times the probability of selecting a white pair of socks on Tuesday. This is going to go to my friend Rebecca.
4 out of 8.
4 out of 8. There's 4 because we used up one of the white pair, right? And we also used up a pair. So there's no longer 9 pairs in there. There's 8 pairs. And there's no longer 5 pairs of White Sox. There's 4 pairs. Okay, so you multiply this together and you get 5 times 4 is 20. 9 over 8 is 72. And what does that decimal come out to be? Let me hear from Jason. 20 over 72, the decimal.
You got 0.27, a lot of 7s and
0.2 with a bunch of 7s and then an 8. Okay, technically, this is 0.2, and the 7 repeats forever. Okay? But if it's going to be 0.277, what would that round this second 7 up to? An 8. There it is. Now, if you wanted to give that to me as a fraction, you would hit math, enter, enter. And what is that? 5/18. I don't really care about that fraction as much, but some people do. So 0.28. And the simplified fraction is 5/18. Very good. Any questions there? Okay, this next one I'm going to leave you to do for homework. But I want to do these two together. The next 2 questions are the same question with one major difference. See if you can find that difference and circle the difference in these 2 problems. Okay. Circle the difference. Okay, so did you figure out what the difference was? Let me hear from Selena, not here today. Let me go with Haley.
One says replacing, and the other one says without replacing.
One says replace, and one says without replacing. And that's monumental. Okay? The difference of these answers depend upon those words. So here's how this goes down. The probability of selecting a dotted tile and then a dragon tile is equal to the probability of selecting a dotted tile times the probability of selecting a dragon tile. Now that's for this problem. Well, what would it be for the next problem? The probability of selecting a dotted tile and then a dragon tile. I should say then, by the way. On both of these. Either way, it works out the same way. Dotted, then dragon, is going to be the probability of selecting a dotted times the probability of selecting a dragon. Okay, I'm sure you could figure that out on your own without me. Okay, so let's go to the very first one. The very first one says we are replacing. In a replacing situation, is this independent or dependent? You say it. Independent. So, what's the probability of selecting a dotted tile? Let me hear from Brian.
4 out of 15.
Bingo. 4 out of 15. Very good. Times the probability of selecting a dragon tile. This goes to Zach.
What is it, the dragons?
Yeah, that's dragon, and that's all the dragons.
So it'd be 4 out of 15?
Try again. Dragon. 3 over 15. Very good. 3 over 15. So what does that decimal come out to be? 4 times 3 is 12. 15 times 15 is 225. 12 over 225, what does that come out to be? Decimal wise. Let me hear from Ben. Not here. How about Moultrie? Jackson.
Or just say it's
12 divided by 225. What'd you get? In your calculator?
Oh, was that just, what's
What's the decimal?
the point of
0.05. That's right. That's right. Now that goes on. You rounded that, right? So if you hit math, enter, what does that change to as a decimal or as a fraction? 4 over 75. Is that what you guys had? Okay. Once again, the 0.05 is really what I'm looking for. That's the biggest thing to me. Now, next, let's do the exact same problem, but now we are not replacing. So what's the probability of selecting a dotted tile to begin with? Let me hear from Madison. So what?
4 out of 15.
Yeah, it's 4 out of 15. It's the same thing as before, right? But now, we're going to multiply this times the probability of selecting a dragon tile. And is there any differences here? Clayana?
That's 3 over 14, right?
It's going to be 3 because there's 3 dragon tiles. out of a total of 14 tiles because we took one and we did not replace it. Very good. So this is equal to 4 over 15 times 3 over 14. And put that in your calculator. Tell me what that equals. Decimal lots.